Education is the cornerstone of progress, empowering minds to unlock their full potential and shape a brighter future. It is a bridge between aspiration and achievement, guiding us towards enlightenment and fulfillment. With this, we begin our today's session on Talent and Future Tech Summit. I, on behalf of WIPS TC School of Engineering, would like to welcome our esteemed guests and future leaders to the second day of Talent and Future Tech Summit 2024. We are honored to have with us today our Honorable Chairman, Sir, whose guidance and leadership has given the way for our journey towards excellence. I welcome our guest of the day, Dr. P.C. Deshmukh, Adjunct Professor of Physics, IIT Tirupati, Rashtriya Vidyalaya Chair Professor, School of Computer Science and Engineering, Rashtriya Vidyalaya University, Bengaluru. I welcome Dr. Sudha Deshmukh. She was Dean of Sciences, Jain University, Bengaluru, Director of Center for Postgraduate Studies and Research. Post-retirement, she was Dean of Academics, IISER, Tirupati. Thank you, ma'am. I also welcome now Shri Uday Birji, sir, Professor of Practice at WIPS TC, co-founder and director at Things Street Technologies. I now request Uday Birji, sir, to please give an introductory of the today's session.
So I'll start from here. Happy morning. Happy morning. Fantastic. As I think I'm always indebted to the VIPS management and my, I would say, inspiration, Dr. Vats and Vineet ji and Deepali ma'am. I think they have given me so much opportunities. I think I can't control my own excitement. And yesterday was an exciting day. How many of you were here yesterday? Fantastic. I think I could see that energy and excitement with all the sessions yesterday. And see, what are we trying to do? There is so much of excitement in the country today, in Bharat. That is what, with whatever capability that we have, seniors like us, we are trying to bring that to you. You may be not aware so many things that are going on, and we are trying to introduce that to you and trying to bring that to you so that you could be the next, or rather the current champions of change as we move to Viksit Bharat. For the next 25 years, you are the innovators. I think we talked about that quite a bit yesterday, and even earlier I have been talking about it. So what I want to thank Dr. Deshmukh. He is our, I would say, my newest guru, inspiration. I don't know how. I think I would like to thank Almighty for accidentally meeting him in Indian Institute of Science. And we immediately brought him into our group, which is trying to do something in the semiconductor space. And they're all distinguished people. I think, people like him and Professor Sadgopan in Bangalore are the inspiration for people like me. And I'd like to thank you and Sudha ma'am. I think, taking time out of your busy schedules. So thank you very much. And I think yesterday Subbu talked about proactiveness. Okay. Dr. Deshmukh is a fantastic example. At his age, fantastic example of proactiveness. I never called him. He said, I'm going to Delhi and you've been talking so much about VIPS. Can I come and meet your, professors and students? That's what he said. I mean, this is a perfect example of proactiveness. So at his age, if he can show that proactiveness, I think you must be 100x of that. Okay, thank you, sir. Thank you for proactively, and you still have a busy schedule for the rest of the next 2 days. So I don't want to, I am a novice in quantum computing. Whatever Prime Minister Modi has been saying, only that I can parrot. And I'm also waiting for listening to Dr. Deshmukh about quantum computing and what we all can do for it. I always used to think quantum computing is beyond me, but I think you brought it to us, sir. Thank you. And I just have a few slides. I mean, some of it is, from the initiative. How many of you heard of NQM? National Computing Mission. As I said, there is so much of excitement happening. Last 1 month or so, we had so much of excitement on the AI space. Now, parallelly, the government is investing $1 billion on NQM, and already the work has started. And I will share with you a little bit of what NQM is, just a few, maybe about 8 to 10 minutes, and then I'll hand over to Dr. Deshmukh. So this is, I think, a snapshot of what this NQM is. And though this was announced last year, 2023, I think August, in the budget session, not August, April 2023, in the budget session, it was announced. But now the actual allocation of funds has happened, and I'm seeing the Ministry, MeitY, and various other organizations already, in fact, the DST, that is Department of Science and Technology, already is invited bids, to set up quantum computing, labs and various initiatives. I think we will talk about that later at some point. So this is, I am told this is almost $1 billion now, outlay of $1 billion for 8 years. Very few, I am not seen in my lifetime in a country like India, putting in $1 billion in something which is unknown and something known, something which is required for a country like India. And this is the excitement. And think of this, all this is not just going to get poured into institutions or whatever. Think of the way you guys can innovate and, solve India's problems. It is going to create thousands and millions of jobs across the country. Okay? So here's one initiative I saw, which has already come into action, which is by Amazon. Okay, this is another snapshot of what the quantum computing mission is. There are revolves around 4 T-hubs: quantum computing, quantum communication, quantum sensing and metrology, quantum materials and devices. I guess you're going to talk a little bit about some of these things, at least what it means to all of us. Here's one fantastic initiative which has already taken place. I mean, it's not that all this is lip service or it is just on paper or whatever. The action has already started. Here's a fantastic video I saw for a partnership with Amazon, the Government of India and Amazon's partnership.
Set to accelerate a future powered by next-gen technologies. But there's one technology that underlines all the others: quantum computing. Perhaps the most innovative technology that changes the computing paradigm. Quantum computing works on the principles of quantum physics and has extraordinary potential to provide breakthroughs in science and technology. As India stands on the cusp of a new future, we need to unleash the true power of quantum computing. And the Government of India is also taking a pioneering step in this direction. We have identified 3 tenets as key to success of the quantum computing initiative. An initiative that can transform industries and enterprises like never before. Today, AWS is proud to collaborate for India's advancement in scientific discovery, technology advancement, and economic growth. Welcome to the MeitY Quantum Computing Applications Lab, established with Amazon Web Services. It's the first quantum computing applications lab globally on AWS to support our government's mission, providing quantum computing as a service to researchers, scientists, academics, and developers, enabling them to explore and create new possibilities aligned to national priorities. India, it's your time to lead and transform using the power of technology.
The video itself generates so much of excitement, especially for you people. What do you think? Right? But to discover what it can be done, I think that's where Deshmukh ji will tell us about it. So I have On the last slide, I normally, end my presentations with at least something that you should take back beyond the technology. So I think we keep hearing about, how many of you know about work-life balance? You are still not in the working mode, so you will, maybe in about 18 months from now, you will be in that mode. I think this is possibly the most important thing which I learned when I went to Harvard Business School. And this is a book by my professor, Bill George. And if you have an opportunity, please buy this book. In fact, I wanted to buy and give it to Dr. Watts, but the editions were not available. Maybe my next trip, I'll bring this book and give it to him. This book covers some of the best known leaders like Narayan Murthy, Ratan Tata, and you must read this book. Okay, if possible, buy it on Amazon and so this picture is self-explanatory. I think, just imagine all of us are expected to work. I mean, Narayan Murthy ji said you have to work minimum 70 hours or 80 hours, right? So there was a whole lot of debate all around the world as to really can we work. Just imagine, any of you can work 80 hours continuously for 3-4 days? No, right? You need to eat, you need to sleep, you need to, socialize, you need to exercise, you need to play, so many things. The similar way, I think there has to be a balance. As you move up in life, there has to be a balance between various aspects of your life. Okay, this is, I thought, the most perfect example that, within your capacity, you have to maintain the balance between all these 4 parameters. Your contribution to the community, personal life, there cannot be a perfect leader if one of it is suffering. You cannot have a bad personal life and say that, you are a great leader. This is what you need to learn as a youngster. Okay? Thank you very much. This is what I want to leave you. And yes. Ma'am. Yep.
Thank you so much, sir. In the spirit of knowledge and pursuit of excellence, we pause to honor the guest of the day. I now request our Honorable Chairman, sir, to kindly felicitate Dr. P.C. Deshmukh, sir, and Dr. Sudha Deshmukh, ma'am. Sir, please. Thank you, sir. At Vivekananda School of Engineering, we pride ourselves on offering the best-in-class lab infrastructure that sets us apart in the realm of technical education. Our cutting-edge laboratories are equipped with latest technology and tools to provide hands-on learning experiences that prepare our students for real-world challenges. With engineering streams in artificial intelligence and machine learning, AIML, artificial intelligence and data science, AIDS, industrial Internet of Things, IIoT, Computer Science and Engineering, CSE, and Electronics Engineering with VLSI, we ensure our students are well versed in the most in-demand fields of future. Vivekananda School of Engineering paves the way for promising career in engineering. I am honored to introduce Shri Dr. P.C. Deshmukh sir. He is an Indian physics and educator known for his contribution to theoretical atomic physics, collisions and light matter interactions, ultra-atomic processes, and applications of Lambert W function in pure and applied physics. Professor Deshmukh, he did his PhD from Nagpur University in 1979. From 2002 to 2009, he served as Senior Research Associate at International Center of Theoretical Physics, Italy. He served as a professor from 1984 to 2016 in Department of Physics at IIT Madras. In 2016, he joined IIT Tirupati as Professor of Physics and Dean of Sponsored Research and Consultancy. I now request sir to please come and share your insights with us.
Am I audible? Am I audible? Okay. Good morning, everybody. I'm thrilled to be here. Thank you, Udayji, Dr. Vats, Deepali ji. It is a great privilege for me to be here today. A great honor as well, and a very inspiring moment for me. I'm very impressed by the initiatives over here. Man making, character building, nation building. This is your mission. This is amazing. And this comes from none other than Swamiji himself, from Swami Vivekananda. He has been an inspiration to generations. Generations before me, my generations, and generations after me. Swamiji, his character was so unique. A lot of people have said many things about him, and I can quote anybody, but I've chosen to quote Netaji Subhash Chandra Bose on Swami Vivekananda. He says, reckless in his sacrifice, unceasing in his activity, boundless in his love, profound and versatile in his wisdom, exuberant in his emotions, merciless in his attacks, but yet simple as a child. He was a rare personality in this world of ours. He goes on to say, Swamiji was a full-blooded masculine personality. And I've chosen this quotation with a purpose. He was a fighter to the core of his being. He was consequently a worshipper of Shakti and gave a practical interpretation to the Vedanta for the upliftment of his countrymen. Now, I chose to begin to talk with this because I'm talking to future citizens of this country. The message here is your health, fitness, be very strong and be prepared to attack what is wrong. I think there is a tremendous message in this, and all of you are very fortunate to be here at the Vivekananda Institute, which can really shape your life in a very big way. It's a great privilege. So I would like to congratulate all of you for joining the Right Institute. I think this is a wonderful atmosphere over here. Professional studies. What kind of professions come to your mind? Teacher, scientist, medical professional. Your chairman began his career as a physician. Engineers, computer specialists, nurse, electrician, carpenter, street cleaner, toilet. You can think of n number of professions. Anything that can give you an opportunity to become a man making, character building. You can lose anything, somebody can take away your shirt, but nobody can take away your character. Man making, character building, and nation building. All of these professions, they contribute to build the nation. The country cannot exist without any of these. So I feel very proud that I am at this institute which has for its goal these ideals. So health and fitness is very important in this. I'm sure you have opportunities for many adventure sports, usual traditional sports, outdoor sports, indoor sports. If you already are into sport, if not, get into some. I would like to mention that I got into adventure sports at a fairly late age in my life. Somebody had told me that I was your age. I did not have that. But at a late age, I got into trekking and mountaineering. I set up the first mountaineering club at IIT Madras. Took several treks to the Himalayas, including Ladakh, which you were mentioning, Zanskar Valley and other places we have been to. I got jump hurdles, very interesting. And these really changed my life because it gave me confidence. It taught me that yes, there are things I have never done, but which I can do now. That was a huge lesson for me. It impacted me in many things, which is why I continue to learn after my retirement also. I had PES that I got into computing after my retirement from IIT Madras. IIT Madras has a retirement age of 65, so I retired from there. I'm not more than 70. I have been using quantum mechanics all my life, but it's not the same as getting into quantum computing. So quantum mechanics certainly lays the foundation for quantum computing, but quantum computing is a very specialized area, and I was able to get from IIT Madras during the years I was at. It's a great privilege because, you know, Swami Vivekananda, when I was your age, I read his books, the Karma Yoga, Bhakti Yoga, Jnana Yoga, and Raja Yoga. I was most influenced by two of these books. One is Karma Yoga and the other is Jnana Yoga. I did not connect easily enough to the other two. And I was reminded of what I had read in Balagangadhar Tilak. He has written a commentary on the Bhagavad Gita, and he says that this is something that you must learn when you're young. A lot of people in our society learn these things after they have retired and nothing worthwhile to do. What it says in his preface, in the introduction to the Gita Rahasya, is that you must learn it when you are young, because then you can use it in your life, not when most of your life is gone. So that's the right time, and you can learn many things from many different sources. One thing that appeals to me in this institute is the focus on disciplinary studies, because that's from what little I know about studies, is that there is strong encouragement to studies in interdisciplinary areas. So this is very important, and I would like to toss a few ideas over here. If you look at it's like, let me suggest a sequence of numbers, like 525, 125. You know what I'm doing? 0, 1, 1, 2, 3, 5, 8, 30. Now, well before Fibonacci, this was actually known to mathematicians in India. It was known to other mathematicians, including, I think, Pingala. It was known earlier. Now, the importance of the sequence, some people call it as the Hemachandra sequence now, not as the Fibonacci sequence, is it leads you to fractals. Are you all familiar with fractals? If you look at a cauliflower, okay, and you see pieces inside the cauliflower, they look like the whole of the cauliflower. If you take smaller parts of it, they look like the earlier part, and you can keep going deeper and deeper in the structure of these. So fractals are objects of this kind. And what is interesting is that when we talk about potential space, if you look at this, say this is one dimension, take the other side, it is, take another one, third dimension. Fractals are objects which have fractional dimension. That is the reason they are called as fractals. I would like to quote, what is his name? Gerd Binnig. He is a Nobel laureate. He got the Nobel Prize for inventing the scanning tunneling microscope. Binnig said that the study of fractals, which belongs to the entire discipline of the theory of chaos, he predicted this, I think around 1989 or 1990, that fractals and the theory of chaos would make as much a revolution in science, engineering, and technology as quantum mechanics and relativity has done in the previous century. So one of my recommendations over here would be to initiate study of the theory of chaos, because it is bound to make a difference. In all branches of engineering, medical practices, the ECG signal that you get sometimes shows fractal behavior. The cells, subparts, you get into fractal structures. So it is having applications in all branches of human knowledge. So that would be an important recommendation I would like to make to this school. One way of doing it is for students to launch studies, because there is nothing like experiential learning. So take up projects, do new things which has fractal applications. You have a rich heritage in this country in music. Means People used to come to India to learn mathematics, astronomy, and even medicine, Ayurveda, but they continue to come to India to learn classical music. Take up a project in which you can compose new music using fractals. Like if you take up some raga, like Malkaus or something, or any other raga, select a set of notes and see what you can do with those notes by repetitive applications. You can compose new music, write a code for that. You need to be very proficient in coding in tomorrow's world. Projects in which you can find new applications of fractals could end up inventing new mathematics. Let me tell you the story of a young, this was 400 years ago, thereabout, 17th century. He was about your age. I think most of you must be close to 20. Thereabout, plus minus few years. This student was 21 years old. He was interested in watching the planets, how they move. And he asked himself, can I predict the position of this planet tomorrow? Where will it be tomorrow? I see it here today, it's going to move, where will it be tomorrow? So he's looking at a certain angle, and tomorrow it will be, right? How will you predict where it will be tomorrow? You need delta t in the limit delta t going to 0. You need d theta by dt. You need rate at which the angle. And he was looking at it when there was no calculus. The idea of a limit did not exist. The limit of a function, that okay, what happens to the value of a function as the parameter gets to a certain point. Calculus, which did not exist. This was Isaac Newton. But then, if you go deeper, you will find some of them probably knew even before Newton. Because otherwise, could they come up with the Panchang so accurately? This is a matter of investigation. I have friends who are to talk about it, so I will not get. These are fascinating areas in which you can contribute to knowledge in a very big way. New mathematics is invented one of the fundamentals is to get continuous and accurate value of position. This is known as the Heisenberg's principle of uncertainty. Why is it important? If you look at any object, there is a water bottle over here, and I keep it here, and I ask you to tell me what is the position of this bottle and what is the momentum of this bottle. The reason these two properties are important is because if you look at any object, you can talk about a number of physical properties. You can talk about the color of the object, you can talk about the shape of the object, you can talk about the mass of the object. Okay, many properties can be thought about. But when you want to talk specifically about mechanical properties of the object, then you're talking about motion and dynamics. And the color doesn't matter, because whether this bottle contains water or milk, if I drop it, it will fall at the same acceleration due to gravity, which is 9.8 meters per second or whatever. So these are the mechanical properties, and only two fundamental mechanical properties will determine all the mechanical properties. These properties are position and moment. So you recognize, you appreciate the importance of position and momentum. Now comes the question, how will you get this information? Who gives you this information? What is the position of this bottle now? To be able to talk about the position of this bottle at this point of time, I need to set a coordinate frame of reference and say that, okay, this is my x-axis, this is my y-axis, this is my z-axis, and then tell you what is the xyz coordinates of this. Then I have to carry out some measurement and determine the rate at which it is moving, get the velocity, and with that I can tell you what the momentum is. Now, without these experiments, there is no way I can talk about position and momentum. And this is the important thing about these two physical quantities. Can I get the position of this object if there was no light in this? I possibly could, the way blind people do. I can stretch my hand, go this way, and then say, oh, the bottle is here. So I could still tell you. And if I had a good judgment of space, I could tell you that it is at, 1.5 meters from where I am. But I need to do some experiment. Either I have to scatter light, either I have to bounce light from it, or touch it. Or maybe if it has got an odor and I have a strong sense of nose, then I could say that, okay, it is in this direction because I get the smell from this side and not from that. But you need a sensor. And without that probe, it is impossible to tell where the position is. And we agreed that position and momentum are extremely important to do any mechanical study. So let's consider one of these probes. Light has to bounce off this bottle. And how many of you have seen comets? Find comets, okay? You can see some comets. There are good telescopes available in Delhi. You can see some comets. Please go and do that. I'm sure you have read about the comets and you know that the comets have a tail. Does anybody know why it has a tail? Anybody? Loudly. If you have an answer, stand up and say it loudly. Yes?
Read about it. So that would be because of high velocity they are traveling with, and due to the friction it causes a bit of tail to form with.
Unfortunately, that's not the correct answer because there is nothing to have friction with. Its comet is traveling mostly in empty space. So that's not the reason. The reason is that sunlight falls on it. And the sunlight pushes the dust on the comet. And the light scattered from that dust is what appears like a tail to us. How do you know that this is the correct answer? Because the tail is always directed away from the sun. Okay, when the here the tail is directed in that direction. When it is here, it will be in that direction. Okay? The point I'm trying to make is that when light falls, there is a transfer of momentum. And if I want to see this bottle by shining light on it, that light will push it. And the position of that object will no longer be what I had intended to measure. And it is impossible to measure position and momentum simultaneously and accurately. Do you understand the fundamentals of Heisenberg's principle of certainty? It's impossible to do that. And if it is impossible to do that, then how would you study physics? Because you need the position and momentum. Without that, you cannot study mechanical properties. So quit physics, or method to do physics which is not based on simultaneous information of position and momentum. You have to invent new way of doing physics. This new way is quantum theory. It is a mathematical framework which allows you to do physics even if you cannot get simultaneous information of position and momentum. In classical physics, which is the mechanics developed by Newton, or beginning earlier than Newton, beginning with Galileo, Newton, Lagrange, Hamilton, and so on. So you can do physics using this alternative theory. It is now 100 years old. Heisenberg's paper and Schrödinger's paper are about 100 years old. And it was a revolutionary idea because it begins with the tenet that you cannot represent the state of a system by position and momentum. How do you represent it as an alternative? You represent it by a vector Hilbert space. What nonsense is this? I mean, you're talking about physical objects, and now you're talking about an abstract mathematical space which has some analogy to the space that we live in. It is also a one-dimensional space. It has got its own structure, it has got its own mathematical set of laws, and it seems so abstract, which has nothing to do with this bottle. And now you're saying that the state of this bottle, the mechanical state of this bottle, is represented not by position and momentum, but by a vector in the Hilbert space. It is so mind-boggling. An out-of-the-box idea, which would seem like nonsense. It was revolutionary. And the fact that it worked, how did it work? You had to develop the Hilbert space. And Dirac says in his book, one of the founders of quantum theory, that you connect it to physical properties as you develop the algebra further, which means that you have to take a good course in quantum mechanics. Maybe you have to take 2 courses in quantum mechanics, or maybe 3 courses. But it is accessible to undergraduate education. And once you learn this, then you develop the algebra further and figure out that you can describe all the properties of this water bottle using mechanics. Nothing succeeds like success. The theory works. I can accept it, even if it's started out by appearing to be nonsense. It works. It works not just for microscopic particles like electrons, protons, and so on. Sometimes you read books in which it is said that for macroscopic particles, for big objects, classical physics should be used, and for tiny subatomic particles, you must use quantum mechanics. This is a very misleading thing. Quantum mechanics is the correct theory. It works not only for tiny particles, but also for large objects. Not only does it work for large objects, it is not possible to explain everything about large objects without invoking quantum mechanics. So quantum mechanics is a very powerful theory, universal theory. It is applicable to everything, small and big. Whether you need it for big depends on the questions you're asking. If you just want to know a tiny bit about what is the trajectory of a cricket ball which has been hit by Virat Kohli when you see a sixer, and you want to predict how far it has gone, you can do these calculations using classical physics. But it doesn't mean that you cannot do it using quantum theory. The answer you get from classical physics is good enough for the purpose of listening to a commentary and appreciating the shot. But that doesn't mean that it is fully correct. It's not. You need quantum theory even to explain means I'm standing here, I'm not falling through the floor, and you can ask, why am I not falling? Because the floor is after all made up of atoms. Atom is mostly empty. There is a nucleus occupies just about a Fermi distance, 10 to the minus 13 centimeters. And then the electrons around it are at various distribution. But the atom is mostly empty. And through that empty space, am I not falling through the floor? Or why are you not falling through the chair on which you're sitting? The same question. Now this is not, we are not talking about tiny microscopic parts. We are talking about large objects. I think I'm too large already. So, if you want to explain this phenomenon, at some level you have to invoke quantum mechanics. So quantum mechanics is applicable for all small and large objects. I would like to come to quantum theory because I think one of the objectives of this meeting is to trigger a discussion on entering undergraduate programs in quantum entanglement, quantum computing with futuristic applications. I have brought with me a paper, one of the most prestigious journals in science, as some of you may be knowing, is Nature. And this is an article from Nature, a very recent article. It was published on 16th November 23, just a few months ago. It is the rise of the quantum engineer. So let me share, I have got some copies which Udayji has got for me. So let me share this. Yeah, we have some more copies. If you can read it, it is a rise of the quantum engineer. And there are undergraduate programs which some universities have actually started, in which they have initiated a career in quantum engineering. Chaos theory is the first thing that I mentioned, which I think is very important, perhaps as important as quantum engineering is. But I would like to recommend engineering physics and also quantum engineering. Engineering physics is because technology benefits from engineering. And engineering requires fundamental science for its foundation. Engineering physics is a great program because that will teach you sciences, mathematics, which is absolutely important. And then you can develop applications in engineering. So engineering physics is also a very exciting program for the future. Quantum engineering is another discipline. It is unstoppable. I talk about this expressing the state of this water bottle by a Hilbert space. It is a revolutionary idea. This is what people now call as the first quantum revolution. And the reason they do it, because there is a second one in progress. And let me tell you the difference between the first and the second quantum revolution. The first quantum revolution was to represent physical states of systems by a vector space and developing the mathematics to get physical properties out of it, which is quantum mechanics, which is quantum theory. Now this was revolutionary, but very fruitful, because what came out of it are things like semiconductors, lasers, all of these developments came out of this. But it had some questions. And these questions are hotly debated, not by ordinary intellectuals, but by intellectual giants. And I'm referring to Niels Bohr and Albert Einstein. Now, there was a huge debate between Einstein and Bohr. Bohr had an intuitive idea of quantum theory as to why it works or how it works. I think he knew how it works. Nobody knew why it works. What people know now is that it works. They don't know how it works, or they don't know why it works. You're trying to describe nature. If he has a question, I'll be happy to answer. But it required a probabilistic description of nature, a fundamentally probabilistic description. It is coded in the words uncertainty principle, but it appears in many more exciting it has many exciting applications in quantum theory. So you need statistics. And let me ask, when is it that you need the idea of statistics? When do you need probability? Am I taking too much time? How much time? Yeah. You have to tell me how much time I have.
You have it.
Okay. Please just signal me. Yeah. So when your cricket captain goes for a toss and he spins a coin, and he will have the right to choose ball first if he calls out correct. What's the probability that he will get it right? What is it? Half? Because it's either heads or tails. Now, if he knows, I don't have a coin, now I use UPI, so no currency in my pocket. But if I know where I keep the coin, and I know how much, with what force I'm tossing it, okay? I know where the torque is applied, how much torque is applied. I can predict how high it can go. I can predict where it will fall and whether it will fall on head or tail if it begins with the heads up. Can I not? Yeah? So it's completely deterministic. But you're now talking only about a probability of getting your answer right. And the reason is because you do not know. Dhoni is tossing this coin and he does not know how much torque is applied. He doesn't know what is the density of air, what is the humidity, what kind of... So these are the unknowns of the problem. But these are all local unknowns. They're there. If only this information was available to Dhoni, and if he put calculation quickly in his mind, he would win every single toss. Do you agree with that? Yeah? He can do it. So the probability is not intrinsic in the process, but it is because of unknowns. These unknowns are called as hidden variables. You understand the term hidden variables? And these hidden variables are all local. They're right here. They are in where the torque is applied, what is the density of air, what is the humidity of air. These are the hidden variables. And Albert Einstein's view was that quantum theory requires uncertainty and probabilistic expression because of hidden variables. And if only these hidden variables are detected, there would be no need for the quantum principle of uncertainty, which is the Heisenberg principle of uncertainty. Whereas Niels Bohr said that no, there is something intrinsic about the laws of nature which requires quantum theory, which has nothing to do with hidden variables. Now imagine the debate between two intellectual giants. This was first in 1927 at Solvay Conference. Almost anybody who was anybody in physics was there. There is a very famous picture. How many of you have seen the 1927 Solvay Conference picture? Please Google it, get a copy of that picture. That is a fantastic picture. It has got the photographs of the most number of Nobel laureates in one picture. So Dirac was there, Schrödinger was there, who wasn't? The debate continued for many years, from 1927 to 1935. In 1935, Einstein wrote a paper in which he tried to show the fallacy in quantum theory. In fact, in one of the debates at the Solvay Conference, Einstein brought up, he was a genius at inventing what are called as thought experiments. So Einstein suggested a thought experiment in which he would prove that the uncertainty or the probability in quantum theory is because of hidden variables. And Niels Bohr would tell him what was the missing in Einstein's argument to prove Einstein wrong. So Bohr took up this challenge, and he always found a flaw in Einstein's argument. In fact, at one point of time, Bohr invoked the general theory of relativity, which Einstein had missed out, a theory which he had himself developed. A very fascinating story. Please go through it, and you might want to enact the Bohr-Einstein debates over here. Means how one of the students play Bohr and the other Einstein. It will be fantastic. So, 1935, Einstein wrote a paper to show fallacy in quantum theory. Bohr replied, showing the fallacy in Einstein's argument. But the debate continued. But it did not stop quantum mechanics from making tremendous advances. That is a period when semiconductors, lasers, everything came out. 1960s, when the lasers came out. And it took 30 years, I think 1964 or 65, that a young man, he was an accelerator physicist, but he felt that both Einstein and Bohr missed something. Because Einstein was arguing, Bohr was counter-arguing, but neither of them suggested a way out as to how to determine whether the probability in quantum theory is due to hidden variables or was it intrinsic to the laws of nature. There was no method which either of them suggested. So this was suggested by this young man, John Bell. And he came up with a logical scheme which finally results in a mathematical equation. You got a left-hand side and a right-hand side, and the left-hand side must be less than or equal to the right-hand side. That was the nature of the equation. This is called as Bell's inequality. So he said that, okay, if this inequality is satisfied, then there would be hidden variables. If it is not satisfied, there won't be hidden variables. So it was, a matter of, black and white. You have to make a choice. And these experiments were eventually performed, they were carried out, and that is the reason the 2022 Nobel Prize was given to Alan Aspect, Zeilinger, and Clauser for this. Now this has led to what we now call as the second revolution. This comes from suggestions in the early 1980s which were made by Richard Feynman. There were others, Benioff, David Deutsch and so on. And they figured out how to use quantum entanglement to do computing. I'm sure all of you are doing computing, and your entire algorithm is based on the Boolean algebra. 0 or 1, right? It's either 0 or 1. And then you can develop logical gates. Okay, the AND gate, the NAND gate, and so on. And using these gates, you can build circuits and build your computers. So all this computing, even if you're using a semiconductor, which is a quantum device, is called as a classical computer, even if it is using a quantum device. The reason it is classical computer is because it is using classical logic, which is Boolean logic, which is either 0 or 1. Now, nature has a different way of expressing herself. We do not know what it is. We did not know what it is till we developed quantum theory. And this is really an amazing thing. I have not brought any slides or pictures to show, but I will try to explain it in a very simple way. If I have a sheet here, and I make a hole here, and another hole on this side, and I pour sand from the top, what do you expect to gather at the bottom? You expect a heap below the first hole and another heap below the second hole, maybe some overlap and spread. But basically, you expect 2 heaps. When you perform these experiments carefully, what you see, and these are real experiments, I do not know if you have these experiments set up in your labs, but it can be very easily set up in an undergraduate lab using lasers. So I think, do you have the Young's double slit experiment here? You do? How many of you have done the Young's double slit experiment? Wonderful. So you know what you see at the bottom is not a single heap, but you see fringes. You see some place where there is a heap and another where there is none, and you see alternative heaps. And you can explain this result only by invoking quantum theory, because what quantum theory requires is the admission of probability that the particle could go either through slit 1 or slit 2, but both have to be taken together. You cannot rule out any one of these possibilities. How could you rule out any one possibility? You can just close one shutter. Another way of doing it is that you keep both the shutters open, but you shine light below the holes. And whether you see a flash from slit 1 or slit 2, you could tell from which slit it has gone. You can do these experiments. And the results are, I would say, typically ghostly. Common sense will not seem to explain. So I will remember our granddaughter once under a tree, and these pebbles were missing the next day. And she concluded that they must have been taken by a ghost or a witch or a vampire. That was her conclusion. And the results that you get from these 2 slits are really as if they have been engineered either by a ghost or a witch or a vampire. Because if you try to shine light under the slit and find out, then the fringes disappear. This is incredible. It doesn't make common sense, but then that's how it works. Which means that if you can no longer talk about a switch being either on or off, which is the basis of Boolean algebra. Okay, all your logic circuits, all your logic gates work on this simple thing. That you have a binary system, it is either 0 or 1. And what we are discovering now is that you have to admit a state which is a superposition of 0 and 1. It cannot exclude one or the other, and this now becomes a unit for doing calculations. So your unit of doing calculations is no longer a bit, which is either 0 or 1, but it is a superposition of 0 and 1, a little bit of 0 and a little bit of 1. And this superposition is now the quantum bit. What it leads to is entanglement, which is the fundamental basis for teleportation and for quantum computing. I think I will stop here by suggesting that these are important things to learn, because it will be impossible to implement cybersecurity without this. There are other applications like drug discovery. You're trying to find a drug like some vaccine which will be useful against the COVID virus. How would you do it? You begin with some chemicals, mix them, do some chemistry, come up with some drug. It may not work, then you try another. And you have to employ large number of scientists in very well funded, sophisticated labs, and then see how effective the drug will be. Alternative to that, as all of you can think about, is to simulate this. And you do this simulation, but think about doing this simulation using classical binary logic. So you will write a program and you will have an if-then-else statement. How many if-then-else statements would you need for this? In the IIT Madras lingo, we call it as hajar. Okay, it means very many. So it's like asking a question. From here, you have to go to the Qutub Minar. How will you get there? You can choose one way, somebody else can choose another way. The person who chooses this way finds that there is a traffic jam over here. The person who then he has to come back, find another road. He finds that the road has broken down, the bridge has fallen, something, right? So he has to take decisions about going left or right many times. And you're talking about left or right, good or bad, right or wrong, it's 0 or 1. It's binary. And if you use this logic, the algorithm would be extremely difficult. Whereas, if you use the properties of nature, which tells you that the physical state is represented not by either 0 or 1, but by a superposition of 0 and 1. So your code will explore all the alternatives in the same run. Okay, what happens if you go left and what happens if you go right? What kind of situation will you land up with? All of these possibilities would be explored simultaneously, which is why doing calculations with quantum computers will be so effective. So you need it in all branches of human endeavor. And I'm sure some of you can make very important contributions to this field. Udayji talked about the quantum mission. Yes, there is huge funding and great opportunities, but I will also like to caution that it is not going to be easy to tap into this funding, because you need to demonstrate your capability to be able to use it. So you need to do some tiny projects, get into it, show some success, prove that support to your institution is justified. And that's not going to be very easy, it's challenging, but that's something for you to do. We can assist in whatever way we can. I'm in touch with some quantum computing new industries, and perhaps some of you can do internships with them and so on. So we can talk about it later. I'll be happy to take some questions. Thank you very much. Yeah, any question, you can ask about how long it takes for me to go to the airport from my home in Bangalore. Any question? Yes. Yeah, there is a question there.
Recently there has been some debate that quantum computers may not scale well because the number of bits that are there, they are not able to make that number goes higher.
Please say that again, I missed it. Yes.
The number of bits on quantum computers that currently they are not that high in the industry. So what is the possibility that it doesn't scale that well?
Well, the industry is going very rapidly, and people are building quantum computers with a large number. When you said bits, I'm sure you meant qubits, because the unit of quantum computation is a qubit and not a bit. Qubit is a superposition of 2 bits. So now people are already using, but this is very challenging technology. About 1,000 qubits are being used. But it is very challenging, but there is a lot that you can do even with a fewer number of qubits. I would suggest that for your first problems, you just work with 2 or 3 and for yourself what you can do with that. The technology is growing very rapidly. It requires very sophisticated experiments, which is why these technologies are developed only where very large investment is possible. So Microsoft, Google, Honeywell, these are the industry giants which are into it. But I don't think that is a big problem for us. We have to be able to come up with logic gates, quantum gates, which will solve real problems. Yes, there was some question from
Sir, like you said that quantum mechanics or quantum theory is also being used to solve problems for macroscopic objects. So sir, my question is like, it has been said, the great theory of everything, basically the theory that solves problems of all scales can't be developed in physics. So why can't quantum physics or quantum theory be classified under that?
I'm not sure I understand your question. Can you elaborate?
Sir, in physics, there has been quite a debate that a single theory that defines every unit in nature or the space can't be developed. We need multiple theories to explain different phenomena. So as you said, that even macroscopic and microscopic phenomena can be explained using quantum theory. So why is it quantum theory yet classified under great theory of everything?
Well, it solves many problems, not everything. Everything involves various different points of view and different considerations. So if you look at how physics developed in the last century, helping us making progress in this century, there are 2 major theories. We have been talking about, and it has its origins in the fact that the speed of light is finite. In vacuum, it is a constant no matter which observer measures it, which is really very strange. Because if you and I are walking relative to each other, and if we look at the speed of a car, you will have a different answer for the speed of the car than what I will. Because you have to make correction for our relative speeds. So what came out of this consideration is the theory of relativity, which is called as the special theory of relativity, but then it is a special case of what? It is a special case of the general theory of relativity, which involves gravitation also. Okay, that any two masses have got a certain attraction between them. It has not been possible yet to develop a theory, and that is your question, which reconciles both quantum mechanics and relativity. That's where the bottleneck is. And that has not been possible as yet. People are working on it. There are working on it. They have answers, they are speculative. And it's difficult to test them. It is difficult to say that the theory is correct. It is also equally difficult to say that the theory is wrong. And that's where the challenge is, but that's also where the opportunities are. But there is no theory of everything as yet. And I doubt if there will be one, at least for the next few decades.
Okay, sir.
Any other question? Yes?
Okay, good morning, sir. Actually, my question is related to quantum entanglement. I would like to first ask for definition. What do you mean by quantum entanglement?
Okay, very good question. I would have loved to talk more about it, but good that you have brought up this question.
So what is the question?
Yeah. What's your name? Yash? Yash is asking what is quantum entanglement. So let's go back. I will take some time to answer it. Yeah. Let's go back to this earlier discussion we had that you cannot know the position and momentum together. We reconcile with that. But now I suggest an experiment in which I have got a particle. It breaks up into two identical particles. So two particles are born out of this friction. One particle goes to the east and the other goes to the west. Okay. These are identical particles flying apart. It's like an electron and a positron coming out of the disappearance of a photon. Okay, or it can be a diatomic molecule which bursts. One atom goes to the east and the other goes to the west. And these are identical particles. If it is an oxygen molecule, O2, one atom of oxygen goes to the east and the other goes to the west. Both are absolutely identical. You are there, you measure the position of this particle. And your friend is on this side. He measures the momentum of this particle. And from the position that you have measured, you can tell that the other particle is as much away because both were born moving together, identical particles. They are going together. So you predict where the position would be. The friend on this side has measured the momentum. Got it? And you tend to tell that from conservation of momentum, what would be the momentum of this particle? Can you get simultaneous information about these two particles, both position and momentum? Have you beaten the Heisenberg principle of uncertainty? It would look like that, right? As a matter of fact, this is one of the arguments which was brought up by Albert Einstein. This is called as the EPR paradox. It's named after Einstein, Podolsky, and Rosen. EPR paradox. And the paradox here is that you have proposed an experiment in which you can beat the Heisenberg principle of uncertainty, and if you still cannot beat it, as it turns out, is possible due to measurement, then it can only be if these two particles are connected in some way, which is entanglement. And if you invoke this entanglement, you can account for the fact that you cannot beat the uncertainty principle. So this is entanglement. What is interesting about it is that this argument that we just discussed has nothing to do with how far you are away from this spot or how far your friend away is this spot. You can be where you are. You can be in another hall behind that wall. You can be in another town beyond Delhi, or you can be in some other galaxy. And irrespective of where you are, no matter how far these two observers are from each other, this entanglement would stay. And you might wonder, how does the information pass from one observer to the other if nothing can move faster than the speed of light? Now this is entanglement. It has nothing to do with information crossing, because information is not passing from here to there or from there to here. What has happened is that our perception of here and there has to be corrected. This is what is meant by reality being non-local. Reality is non-local. When I discuss this in my courses, I call it as reality 2.0. Our perception of reality is in terms of a clear perception of what is here and what is there. There is no ambiguity about this. But nature has her own way of expressing herself, which defeats this segregation between here and there. That's entanglement. And this entanglement allows entanglement between two quantum bits. And this entanglement is quantum computing. So teleportation and quantum computing becomes possible essentially because of entanglement. So it is an intrinsic property of nature which requires a superposition of states. Yes.
Good morning, sir. Sir, actually I have researched a little bit about quantum computing. Sir, I just wanted to know about qubits and what are the advantages and challenges in future computing that will arise because of this.
Yeah, it's a good question. It has a very big answer. I don't think I can get into too many details, but I did refer to some essential aspects of advantages of using qubits. A qubit is a superposition of 0 and 1. Okay, it is not the way you do classical computing in which you use either a 0 or a 1 and its physical representation. You can do maps and many things with electronic circuits, but it boils down to a switch being either on or off. Okay, in your algorithm there will be no place where you consider the switch to be a superposition of on and off, and that is what a qubit allows. So I explained it earlier by saying that if you want to go from here to Qutub Minar and you don't know at this point if you should go left or right, if somebody could do a calculation for you as to what would happen if you went left and somebody else did the calculation of what would happen if you did right, because you will meet different situations, different traffic jams, different roads, different traffic obstructions. And that will determine your success in getting to your destination. Now, if both of these calculations are available to you instantly at the same time, without one after the other, otherwise a classical computer will calculate the probability of success by taking either left or right one at a time. If the switch is either on or off, 1 or 0, one at a time. Whereas a qubit computing, quantum computing, will allow you to get the answer by considering both. Okay, means I don't want to get into the mathematics of vector space, but even with a 7 qubit computing, you can get one state and you want to get to another state. And you can ask how many steps will be needed. And I have these numbers on my laptop somewhere. The details are not very important. But if you use a classical computer, you will need thousands of steps. Literally thousands of steps. Whereas if you use qubit logic, you can get there in 4 steps. Isn't that impressive? And the advantage in cybersecurity comes from another reason which I have not mentioned. Because of your question, I have an answer to. Suppose you are sending me something, and we are close friends, we are sharing our secrets. Or there is somebody else, he can interrupt the message, okay? And he can extract that information which you don't want him to know. You want to share it only with me. Apni to yari hai. So somebody else can interrupt and get this message. So the advantage of a qubit is that if you interrupt, that state breaks apart. Qubits are very volatile. So information is very safe. And now with the kind of, I'm sure many of you know how to hack. How many of you know how to hack? Can you hack each other's email accounts? How many of you can do that? Your director is here, she wants to know. Huh? Yeah. All right, but I'm sure that some of you can do that. And I'm absolutely sure that some of them can do that. Yes. But you won't be able to do that if the passwords are secured by quantum bits. There's no way you can do that. There's absolutely no way. It's not a matter of more effort or more time or more computers. You cannot do that. Does it answer your question? Yes.
You told us applications like and cybersecurity. Sir, what are the applications if artificial intelligence and quantum computing are brought?
Amazing. Amazing. Very good question.
Fantastic question. Actually, I was going to preempt that question because.
Very good question. I did not have a chance to come to that because the subject is so vast. But thank you for asking. How would artificial intelligence, yeah. So it's a very powerful tool, but the machine has to do some learning. And if this is enabled by qubits, it's of course going to be far more effective. And QML is already a big force. So it's a very important question. Many things are happening in this field. QML logic is certainly being developed. There are many applications. You can do some projects on using quantum machine learning, which is a subset of quantum applications in artificial intelligence. We did a project recently with undergraduate students, so it's something which is very much within your reach. You can do that. Good. Yes.
PhDs in natural language processing, can we integrate this along with NLP, quantum?
I'm sure you can. I'm certainly sure you can. Actually, there is a similar problem that I have been discussing with another friend of mine, which is on music. So in music, there are some ragas in which there are similar notes, but not the same. So sometimes even if it is the same note, it is not the same usage. The aroha and avroha may be different. So in languages also you have got very interesting and penetrating structures. You need to extract those. You can certainly use quantum machine learning for this. Good. These are the projects you should take up, and they are, I must say, within the reach of undergraduate students. That's the most exciting thing, because people like us cannot immediately contribute to the development of the frontiers, but we can certainly do these problems. Yes.
So I think Dr. Deshmukh ji, I mean, for me, listening to this is, I got goosebumps understanding the nature, the role of nature in this whole science. I mean, we thought it is all about zeros and ones because that's how we have come up. And the relevance in music and the way you explained are fantastic. Thank you. I think it is a brilliant. And in fact, the only question I wanted to ask, I think he's already asked. I mean, because the whole topic revolved around, because there's so much of excitement on AI, right? AI. In fact, last few sessions we all revolved around AI.
Yes. Very true. Absolutely.
Yeah. So maybe I have one observation, sir, because that's the reason I played that video. You must have seen.
Yes.
AWS, that is
yes.
Amazon's, the cloud services that they offer. So you mentioned during your talk that it's an expensive proposition and quite a difficult thing. So with companies like AWS offering quantum on demand or quantum service as a service, will it be more, I would say, feasible to bring it into VIPS?
It will be feasible, and you were referring to MIT's program,
exactly.
And they do offer some access through their programs to institutions. So some of that can be tapped. But I suspect even that will be difficult to access before we can show some work.
Okay.
Because as the ground reality, most of the funding goes to major research players.
True.
Some to the next level and so on. And there are hundreds of universities and even more number of colleges in the system.
Yeah. So that's why I said now the private services player like Amazon, AWS. Now, I think the essence of that service is to make it available to everybody, researchers and innovators or whatever. You think that was the question?
That certainly can be done, but there are easier alternatives.
Okay.
What I would suggest is that tie up with these new companies which are getting into quantum computing. Right in Bangalore, we have a company which is building a 25 qubit computer. And I'll be happy to put you in touch with them.
Sure, sir.
And you can send some students to do internships with them.
Yep.
So it's a small quantum computer. It's a 25 qubit, but not bad. Means you have to get your feet wet. So I think you can certainly take up some projects with them. I'll be happy to put you in touch with them.
No, I think we will build a small closed group, closed quantum computing interest group.
Sure.
Who wants to? I think that's a way to begin. Start small and then enlarge into. But I think apart from the expensive proposition, the difficulty. I was amazed by the one question you answered that on the security aspect, cyber security.
Yes.
I think that makes it for a country like India, which is dependent on
Oh, yes.
American, databases and companies. We can build our own high secure networks.
It is very important because our banking depends on that, our
Correct.
defense strategies.
Aadhaar is also.
Aadhaar, yes. So personal and national security is tied up with that. It's a very crucial thing, and the country has to take up this challenge, and it is these kids who will do that. It's an amazing gathering over here. Thank you all very much.
Any last comments or suggestions you have for the students?
Well, I'll go back to two things.
Sure, sir.
One of which I already mentioned, which is health and fitness, and second is hard work. There is absolutely no substitute to hard work. You have to work very hard, ask questions. All our learning is in the tradition of the Upanishads, and question answer is an integral part of learning. I must say that this is known to everybody, but in most of the colleges, including the IITs where I have been teaching, students often do not interrupt the teacher. Like, one of the things for which I became quite unpopular among some of my colleagues is I used to tell students that do not rag the new students, but do rag your teachers. Ask questions. Okay? Stop them in the class. Interrupt them in the class, find them in the corridor, go to their office and ask questions and demand answers. Don't expect answers because knowledge is vast and a teacher does not have all the answers. So be kind to them.
Sir, I think that
Give them time to get
what you said is in this paper as a bold quote. A technology can't succeed if only the people who know how to use it are PhDs.
Yes.
I think it was a fantastic
Absolutely.
conclusion to your
Yes.
talk. Huh? Yes.
Yes. Very true.
Fantastic. So
Absolutely.
this paper, I have a soft copy. I'll give it to Deepali ma'am. So,
Yeah.
sir sent it to me last night. I was just going to sleep, and he said, "Can you get me some 10 printouts?" So I started reading it, and I finally slept at 12 o'clock. so interesting, very crisp, three pages. I am sure this excites you. I mean, it's
Yes.
just a summary of how computing is going to change, and what is it that you can do. So, thank you very much, sir. Thank you.
My pleasure. Thank you.
So, all of you are happy? Yes, sir. That's all. I don't find too many people, brilliant here. You could have shot up any number of questions to him. And he was ready answering it. And I'm fabulous knowledge, and starting from sports to anything to music to ragas and whatnot, the composition of it. So it is multidimensional, and I think the amount of fabulous knowledge, and being a physicist and something to do with the quantum physics and quantum mechanics, and now in the field of particle physics, as I told, that Large Hadron Collider experiment is going on the border of France and Switzerland. And 150 computer grids, 25 petabytes of information being deciphered in 25 countries. So 35, the 150 computer grids. And what we are trying to find out is the Higgs boson, the God's particle, which I think was 10,000 scientists across the world are engaged in that experiment. And one answer that going to emerge is that there's oneness of all beings here present. So the Upanishads that you refer to, they're very clear about this. There's no ambiguity about oneness of all mankind. यस्तु सर्वाणि भूतानि आत्मनिव न पश्यति यस्तु सर्वाणि भूतानि आत्मनिव न पश्यति सर्वभूतेषु च आत्मानं ततो न विजुह्वते यस्मिन् सर्वाणि भूतानि आत्मनो भूत विजानतः तत्र को मोहः को शोकः एकत्वं न पश्यते. He never gets misled. And Vijanata means it is used in the context of being the scientist of all scientists. Vijanata, not only the science and technology, but much beyond that, he is the knower of all knowledge. If each one of you can feel the pains of others, share their sufferings, joy and the opposite of it. Just look at this, world will be very beautiful. There will be no jealousy, no advice, nothing of the kind. No raga, no dvesh, no love, no hatred. You'll go beyond that. And finally, the science is going to culminate into the one reality. Nuclear scientists has given us many good things, nuclear power, which India has yet to emerge. But the nuclear holocaust awaits. So it's the opposite and the reverse of the same coin. And if you rotate a coin, it is quantum. It's very facets, multi-dimensional. You cannot even have one dimension. You have millions of dimensions. I was telling that bottle and all this different variants of it. So each one of you will have to be an awakened citizen. Arise, awaken, stop not. Utishtada, jagrata, prapivarani bodhata. Arise, awaken, stop not till the goal is reached. You can't be sleeping, or you can't be a pretender sleeper. Most of us are. We were born here where such an enlightened talk was being delivered. How will you get this opportunity? This privilege is being bestowed upon with courtesy, Uday. Thank you so much. And what if people of such an eminence of Professor Deshmukh, and when I read his name, Pranav Chandra, I was completely thrilled. I said, Pranav, he is connected to the ultimate reality, infinite power, seamless knowledge. It's brought here for your benefit, and you don't take the advantage of it and see some people marching up and down the corridor. I don't like all this. I don't want you to be disciplined. No forced discipline. You need to be self-disciplined. Whenever a guest comes, I want complete silence on this. Nobody should be marshalling up and down here. Nobody should stand or open the doors and get out. You want to get out in the beginning itself. Remain disciplined. And that's our interest, longer interest. That's to enhance your employability skills that Mr. Uday is taking all those initiatives. There's a painstaking effort coming from Bangalore and taking up all this, bringing all such eminent people to you. You don't want to avail of this golden opportunity. So my heartfelt gratitude to Professor Deshmukh and Madam Deshmukh. Thank you so much. You are highly scholarly people, and I think you're still in pursuit of the highest knowledge. And we are really, it's a rare privilege to have people of your eminence and people who know physics very well in all its dimensions. May I request each one of you that what discipline you, Gopal, you should never stand. None of my faculty members should stand and discipline these boys and girls. They are responsible people. They will have to own responsibility now. They will have to come up. We want responsible citizens. If this nation has failed to cultivate is responsible citizenship, and that can only come through forced discipline. If you don't self-discipline yourself, teacher teaches you with sympathy. Teacher teaches you with sympathy. Nature teaches you with vengeance. And vengeance, when it is let loose, calamities like cyclones, tornadoes, unpredicted. And the best of meteorological scientists, they will not be able to predict many cyclones which have hit the coastal areas of Odisha, West Bengal. So teacher teaches you with sympathy, nature teaches you with vengeance. You will come to grief one day if you don't listen to such eminent people. It's worth $1 billion, knowledge that he imparted here, but some of you are half asleep and some of you are awakened. Some of the questions which I put to him were out of context. Absolutely out of context. I wish you ask contextual questions related to his talk which is delivered. Not that when they're asking of a question, you want to ask a question. So, on behalf of you all and on behalf of the management, I express my deep sense of gratitude to our most respected professor of physics, and now he's into this quantum computing, very expensive business. And very cost-intensive thing. We can't even think of setting up here because many big players, there's billions of dollars of investment which only can be done by the government, and the government is taking all steps forward, under the leadership of our Prime Minister. Billions and billions of rupees. And if you want to put one semiconductor plant, it costs $5 billion. And 75% of it is being subsidized by the government. So you can look at the amount of subsidy which is being given. Private investors need to only put 1 billion, and the rest of the 4 billion is going to come from the government. So what more encouragement you want in the field of semiconductors? Already 1,000 and I think 500. Tatas have come into semiconductors and microchips, manufacturing. So also another company has come up, 2 of those have come forward, and many more will come. Employment will enhance. Your employment skills you need to enhance here. So thank you very much, sir. We are deeply obliged, deeply indebted to you. Thanks so much. But never ever, whenever somebody comes, you need to show exemplary discipline. Exemplary discipline. This is Vivekananda Institute, right? Thank you.
What is it? Only cell, is it? So we have the placement cell student members and the faculty who are like the mentors, right? So E-cell, that's what, E-cell only, all E-cell only. So I have only about 3-4 slides, so we'll try to finish in 1 hour only and it's more of interactive. I'll tell you what I'm trying to do. So morning we had an official inauguration. I think the most distinguished, everybody attended the session in the morning? So it was so intensive. I mean, for me, it was an enlightening session. I hope all of you enjoyed the session. Fantastic. I mean, I have never attended such a session. And for me, quantum computing itself is, maybe you people know more about it, but the way he delivered the talk was simply superb. And you know that he is in IIT Tirupati. And we were just chatting over lunch with Chairman Sir. I think if you look at the Indian knowledge system, the Indian scientists, we were already using quantum mechanics or quantum physics. Our scientists 500-600 years back. So we will try to do one more session where we can connect today's AI to what we were, what our earlier scientists were doing. So I think, You attended Subbu's session, right? Subbu and Harsh sir and whatever brief talk I gave yesterday. E-Cell today is, in fact, I would say for whatever reason, VIPS is already late. But VIPS is, a growing college. So, the first batch, better late than never. I mean, I think so. Today, E-Cell is launched in most of the colleges right in the first year itself, which means the first or second semester. I have helped, Vellore Institute of Technology, VIT, which is an institution of eminence, to set up this E-Cell. And the similar model is what I have sort of brought in here, with some changes in, the titles or the responsibilities or whatever it is. So this one, E-Cell and the placement cell, will play an important role in your careers. That is something you should understand. This is not like the clubs that you have. I know some institutions call them as entrepreneurship club or whatever, or innovation club. But this is not like something for an entertainment or, just a, social kind of an activity. This is something very, very serious. It will not only bring out your entrepreneur's spirit, but you also hold a responsibility for all your batchmates, immediate batchmates, juniors, and maybe the future batches also, because you are setting the foundation for VIPS School of Engineering and Technology. So that is something which all of you should remember. So at maximum passion, maximum dedication, and of course you have to go beyond your curriculum, spend more time. Like the ma'am was saying yesterday, the placement cell will require additional time. You have to cut down on some of your other activities. Maybe, I'm not saying in your family or sports activities, at least on browsing social media or whatever, cut down on that and concentrate on this one and the placement cell. Okay. So, and almost, I'll tell you, I studied in BMS College of Engineering. BMS is one of the top 3 colleges in Bangalore. It's almost, it started before IITs also. When I quit HP in 2014, they did not have an E-Cell. Okay, and they are such an advanced college. So, a lot of colleges are also realizing late. But one good thing is, what I have noticed is, see, when I quit HP in 2014, when I started interacting with colleges, this E-Cell activity or innovation, entrepreneurship used to come in the last year or the last semester or last 2 semesters, let's say 7th and 8th. Today, as I told you, it is coming from, they are trying to give you, mentorship or mentoring on entrepreneurship right from the first semester. And I get invited to do the induction for the opening batch. On the first day, they enter the college. Tell the students about entrepreneurship and innovation. So one way it indicates the kind of opportunity that is there. And also, see, jobs are always scarce. Though we are all trying our best to, with all the skill development and the placement and all, I am not expecting 100% people will take jobs. I'm not expecting 100% people will be placed also. Okay, it has to be a mix of both. Correct. So also we would like to address the passion. Somebody doesn't want to be, in a corporate organization or whatever. They want to work for a few years and then take up entrepreneurship. And some people, I know some people, not just IITs, even in normal colleges, they float a private limited company in the 3rd semester, 4th semester itself. And I think once this gets established, this institution also should encourage that. Which means as you are studying, start a private limited company, and the college may, give you some kind of a, small token investment or, whatever, and take a stake. So all that you learn through this E-Cell that we are bringing. So this is a journey we are starting. And I think 1 month back, we did some kind of a informal selection already. And now the team is settled. So the idea is to, ensure that energizing this e-cell is in your responsibility. We are here as mentors. We will support you. We will do whatever is required, and we'll bring in more mentors also and industry experts for each of the topics. Okay, whether it is green energy or like quantum computing. In fact, Dr. Deshmukh has offered, saying that a few students, so we may be able to help them get internship in 1 or 2 institutions in quantum areas. So such things we will keep doing, but in terms of keeping the e-cell energized, it's your responsibility. And ideally, this is the team, the e-cell team, it's a 1-year responsibility, which means 2 semesters. So the next, after 2 semesters, we will have a new team. Okay, that is how it is running in most of the colleges. And also we will bring in, I think you know that IIC, right, Institution of Innovation Council, which is under the Ministry of Department of Science and Technology. We'll bring in some policies and methodologies here, which will help the college get some, weightage as accreditation and certification happens. All that we will do. So right now, so this is what I had a few things. As I told you, I have. These are some of the things that I will talk about. Who will do what? You need when you make a startup, right? When you do a startup, the first thing you do is, what do you do first? You make like an elevator pitch or like a business plan or like a pitch document as to what your startup is all about. The vision, the market opportunity, the go-to-market strategy, the marketing, the team, all these aspects. So similarly, you must make a e-cell pitch document talking about your college and what are the activities you will do. I have a template. I'll send the template separately to Deepali ma'am, and she will forward it to you. And each of you can fill up those whatever in the template. There are different parts in that. I may have a template. I'll see if I can show it to you. And then roles and responsibilities. I have one document which we did for Vellore Institute of Technology, VIT. I'll just display that. So, and we will sort of edit that and make the roles and responsibilities specific to VIPS. Okay. In fact, I'll request Deepali ma'am to just edit it. See, roles and responsibilities, whether you're in VIT or IIT or VIPS, more or less it will be the same. When you are talking about head of marketing, I think the activity will be the same. But the environment may be different. The facilities, the infrastructure will be different, or maybe some plans will be different. But the role at a higher level will be the same. So you have to make, let's say the marketing head will have to make specific marketing plan for e-cell of VIPS. That will change. Okay? And I'm expecting maybe in the next, by March end, we should have a 2024 roadmap, all done by you guys. Okay, so you will make this first. I will display the roles and responsibilities. Then 2024 roadmap means a plan. What all you will do in April? I will do a e-summit. Okay, in May I will do your team. When I say the e-cell will do maybe an investor summit. Or maybe in June you will do a hackathon on maybe IoT or AI or whatever. So that is the roadmap you have to do. And you have to stick to it as much as possible. You have to look at your exams, your, whatever activities that you have, and you must have a 1-year plan. So it is like running a startup itself. You have to be very, very specific and put the times and the timelines properly. And the finance person, means the person who is also taking care of the finance part, should also indicate what could be the cost. So I'm not expecting very cost, heavy activities here. Whenever there is a cost required or expense required, we will see. We'll address that, by specific thing. Collaboration with placement cell means, as I told you, see, when the placement cell members go to, let's say, Deloitte to pitch, right? To pitch saying that, hey, this is a great college. So you must ensure that e-cell is a part of that. When they pitch, they must talk about how great your e-cell is, what is the kind of team you have, what are the activities you are doing, what all activities you have done already. So that should be, so you should collaborate with the placement cell as well. So you should work in sync, because finally the person sits, the hiring manager in Deloitte or EY or wherever, or Google, any company, they look at what kind of an e-cell you have, right? And what are the activities that you are doing, and what is the benefit that you, how the students benefited, how is the college, taking mileage out of it. So, okay. And I think I already told you, yesterday also told you, then the previous, I think last month when we came, this, Center of Excellence is a separate activity. So there will be a separate Center of Excellence for futuristic technologies and skills, which will again run like a, independent organization, okay, with partnerships and with some tools and whatever that is required to make it like a world-class TOE. So you must be able to use that. You may want to run a hackathon using the Center of Excellence on specific technologies. Okay? So this is one part of it. And the last part here is, how many of you are all of you are members, right, of the ESL?
Actually, there are 14 heads.
Yeah.
All the rest are members.
Means, okay, I think you should make a closed group, WhatsApp group to start with. Huh?
Executive committee.
Yeah. So you make a WhatsApp group. Right now in the beginning, you can add me and of course, I am expecting Deepali ma'am and Harsh ji and 2-3 other mentors like Madhav ji and all. We will help you run that. Means some ideas and once you make the pitch document, you can send it through on the WhatsApp and we will see how we can help you. And then regularly, most of us are outside. Me, Madhav, we are all based in Bangalore. But we will actually, in spirit, we are here. Okay? So we would like to run some, online mentoring sessions, groups mentoring sessions, or advisory sessions or whatever. So all that should become a part of your roadmap. Right? So this is what, so you right now in the next whatever week or so, you create this group, add a few of us, especially Vinit ji and the Deepali ma'am should be there, and me, Madhav and 3-4 members, you add that. Okay? So that we can monitor the activity, give some suggestions, and of course, Harsh ji also should be added. Something happened? No. Please, Harsh ji is new, so you add him also. Okay? So this is the broad, I would say, plan for ESL. So I have a document on the roles and responsibilities. Let me display that. Okay. So you're able to see? Okay, so here only the title, you see in VIT we had run it like a real company. We are calling it chairman, CEO and marketing director and all. So here, I don't know who's the head of the, okay. So obviously the management doesn't want to call you chairperson or whatever, head of president or whatever. So these are the roles and responsibilities which are assigned to you. And as I said, we will make this specific to VIPS and send it to you. This and so you can circulate it to all the team members. So you very clearly, distribute responsibility. So your job is like a CEO, right? You have to distribute and ensure that none of your members quit your company. Okay? So that is your leadership. You have to demonstrate that leadership also. There should not be any complaint saying that he is not paying attention or he doesn't listen to me. All that is your responsibility. Okay? So these are the things, reviewing all incoming and outgoing communication. So this is a set fantastic document. We made it for VIT. And many institutions, I have helped them adopt this, okay? So, I'm just displaying, so the vice chairman, I don't know, is there okay. So, accordingly, we'll change the title. So, what is it that you, vice president? So, president, vice president. So, here you see, vice chairman should, if he has to go on a holiday somewhere with, for, whatever, you have to be like the president. So, that's, all these are, it's like over after 1 year. It should not happen, hey, acha nahi chala, I am not interested, People should be eager, hey, I want to become a part of the, ESL. That's how it should be. You should set the benchmark. Each ESL should be much, better and better. But since you are the first, set the benchmark for everybody. Okay? Vice chairman, then secretary. Okay, fantastic. So I hope you know what the secretary role is. Huh? What is the role? We don't see this. Okay, good. I'm not testing you. I just wanted to understand. So this, I have the most of the office bearers. I have like co-secretary. Is there a co-secretary also? No. Okay, no problem. I think in VIPS we had this. VIT. So creative head and design. So outreach head. Outreach is like more like the collaborations. Yeah, okay. So finance head who takes care of all the accounting and things like that. Yeah. Oh, you are what? Okay, good. Collaboration. Yeah, good. So collaboration, outreach means a collaboration. Okay, who's the creative and okay, social media creative or only creative? Creative head and design head. Okay, so these titles will change. I'll send this document to Dipali ma'am, and she will get, or rather you can only change it, and this will go into the record, the files. Yeah. Yeah. No, this has to go into the record, saying that this is your responsibility. Yes, it should be in records, like a company record, no? The company secretary keeps records, right? Like that. Okay, and then editorial head, like the, so what is your role?
My role is to present what our society does, all the functions, all the everything, the to-dos and all the happenings that is happening in society.
Yeah, so to make it easy for you, we have listed down all the responsibilities here. And as an example, I'm giving you the roadmap that earlier I showed you the slides should have the roadmap or the plan or whatever. The roadmap should contain periodically once in a month you're going to release like a newsletter. Newsletter not only for this, the entire college. A new ESL, VIPS, School of Engineering and Technology, ESL should reach everybody. All the students, and check with ma'am if it can go to other law students also or whatever. Check the feasibility, and then, but it should reach at least all your first, second, and third year batches, and next year the fourth year batches also. Okay, that kind of a plan should be in that roadmap document that I mentioned. Okay, so events. Who's the event manager? Okay, so are you going to get? So events, you see, the event side should plan programs that satisfy. Okay. So what's your event? What do you think the event? Correct. Like for example, we brought Dr. Deshmukh. These are the people. Through your own contacts, through our contacts, through Chairman, Dipali ma'am, Vinitji, through such kind of contacts, you must do your research, find the relevance, and ensure that, I think Chairman gave feedback, ensure that they get the respect that, when they come here for a talk, or you do a panel discussion or whatever it is, okay? Yeah. So I think you are said. I mean, bringing Hema Malini or Shah Rukh Khan is some other club's responsibility. Yours is focused on entrepreneurship and innovation only. Okay? Publicity, PR and marketing. Okay. So what do you think you'll do? True. Yes. VAPS eCell should become a brand of its own. I don't know, maybe we don't have to do everything that we have done in other colleges. You may want to give it a name, no, like a Sanskrit name, I don't know. eCell. Whatever. So you think about it and give a nice name. But English में होना चाहिए eCell because many may not understand the name. So eCell, Udyamita or whatever. Think about it and then suggest. Okay. So publicity means actually also external, means not just social media. Maybe we'll see. You should be able to, let's say we do this kind of events, right? Today morning we did a quantum computing thing. The people should know outside, not just in social media. Even sometimes you may want to call some media publication, newspaper or magazines or whatever and say this, they should attend this session as well as, maybe write an opinion article. See, this morning's event, you should be organizing future. I'm not expecting, everybody you'll have such senior contacts. But once, let us say me or Madhav or Harshji, we decide that we are going to do this kind of event by bringing this person, you should do the entire logistics. I'll tell you, I don't know how it will work, but when the first time Vellore Institute of Technology, they invited me, Vellore, it is about 5 hours drive from Bangalore. So there's no airport or whatever, you have to drive. Okay. So right from the taxi booking to booking the guest house, because there's no hotel, really good hotel in Vellore. So right from booking the guest house, taking me to have lunch or dinner, everything was taken care by the students. No faculty was involved. Faculty people came only when the event was happening. So that is the, learning for you. You're running a company. You're not just running a, on paper organization. You're running a company, right? So that is to that level of detailing you must go. And I see in a couple of other institutions also same. The faculty chooses that, see, even choosing whom to bring, as I said, you should play a role. But of course, then the management and the faculty will, say this person is appropriate or not appropriate or whatever. They will do the filtering and say, okay, now you take over and ensure that this person is invited. And maybe invitation letter has to go from the chairman or whatever, email. That you have to take care. Once that is done, once the person accepts that I am coming for the eCell talk, everything should be done by the student, right? As I said, taxi, if I am coming from Bangalore, even the ticket should be booked by you. Not from your pocket, but college. Okay? So that is the level of detailing it has to happen. Okay, so publicity head. So then HR head, there is a HR head, management head. No, right? So I think that HR head and management head, I think the operations person can do that. See, planning, coordinating, supervising the workflow, all this is operations. But actually this, I had also recommended operations only. Those people have changed it to HR head. HR means, okay, we can make it, as I said, human rock stars. Right? Yesterday we talked about it. Okay, project R&D and technical head is a CTO. Who's a CTO? What do you call him? Head, technical head. So this one, anyway, this document will reach you through Deepali ma'am. So R&D. So this we are splitting into two, technical head and R&D head. Okay. So between these responsibilities, you can see how to allocate. try to minimize the overlap. If PR guy is doing some social media, another person should not send another social media, page. Okay. So ensure that there is no overlap. But then again, it creates a outside externally bad. So this is the structure, and this is what the roles and responsibility was. So this is actually any other points or whatever? Yeah. Yes, that was my. In fact, this is not there in the VIT. That was my addition. Yes. Yeah, you add that to this document. Very important. Very important. And that's. I'm telling you, you must thank me because no other college has this. And I thought, it is important to have a women entrepreneurship head or whatever, taking care of that. Yes. And we would like to see women unicorns coming out of VIPS. Okay. Women-led unicorns. Okay. What else? So have we covered everybody, all the office bearers? Or except even one person who's not there, that you will take care, right? Okay, good. So I think, this is ESL 1 year, you'll enjoy it. I am in touch with the ESL members regularly. In fact, I have created a separate group for young leaders. Maybe once you pass out, one of you can join that group later. We conduct, industry sessions. We conduct offline sessions, online sessions. So I think, you will enjoy this. It should not become like a responsibility. It's a learning for you. It's a self-development activity in various areas. Leadership, technology, marketing. All your skills will come out. And you will be able to learn. I think this is a beautiful exercise. And of course, the government has, through IIC, the Institutional Innovation Cell, they have been, promoting this heavily also. Okay. In fact, I had sent one page. Have you created a ESL page on LinkedIn? And,
Yes, sir.
huh?
As you suggested, sir, we also been posting a newsletter. We were thinking of creating it for a week.
Yeah, see, for example, you can start now.
Yes, sir.
This last 2 days today, you make a good write-up,
That we can add some, papers on quantum physics with.
No, see, I'm saying the event should be specific. I mean, the page or rather the post related to the event should be that. Then you can keep on putting educational posts like quantum physics, like this article. I have circulated, right, and on the which sir gave. So such kind of articles, or you can write your own articles, whatever. So you must keep the page active, and all your that page anyway. Social media, it's free. And your entire college should subscribe, not necessarily only the engineering and technology.
Sir, actually, we have also started an initiative. Sir, it is student interest groups, where students will only be teaching the students, like if somebody has a technical forte, then they can be teaching about, say, Canva or any of the things that are utilized in creating. Recently, Google and Niche, the person who is now present, they did on how to communicate, how to pitch an idea.
Yes.
So,
All that, yes.
very basic ideas so that everybody is comfortable with those ideas. And then now we will include some higher concepts also, because then they will not be engaged enough.
So whatever that page should focus on ESL related activity. Don't put convocation हुआ उसका वो डालने का जरूरत नहीं है. Okay, I think focus only on ESL activity, because for convocation or many other active sports, there are other pages. So don't mix up. By mistake also don't mix up. Then you lose the focus. People will not, lose the interest in that. Okay. So any other feedback? Any other feedback? Any other thing? Yeah. So action is on one action is I'll send you. I have one more event tomorrow here for the VIPS Law College. so I'm busy till Sunday. In fact, I'm also taking a 9 o'clock flight. So by the time I reach home, it will be 2 a.m. Okay, so I'll send you the template on Sunday or Monday. I'll send the pitch document template, and this I'll send it. You have to convert that PDF into. You create a WhatsApp group. Only the office bearers and some your faculty mentors. Yeah, and Madhav also, Madhav Visa. Yeah, Madhav Visa. You add and we'll keep it active. Okay? Yeah.
Also, by the way, like we have the idea we have to take the roadmap. Like, it's not on paper, but we did some like online discussion as to what do we want to do next. So, sir, we were thinking that rather than just having what do you say that events, we can have sponsors and then we can have some like the ideas and then we can implement and we can fund those events
Yes.
with the money that we gather from those sponsors.
Yes.
So that way we can
I think,
create
the.
an incubation center.
I don't know. There should have been a head for who's taking care of sponsorships and all. The finance head, is it? Okay. Yeah. You should actually, we must change that to finance and sponsorship. Finance and sponsorship. That's all actually. That's all. So you should be in touch with. There's so many companies. They'll come and spend money. Big companies, Microsoft. I mean, milega. See, you start getting visible, no, on social media and all. Then they will. Now I am connected with so many e-cells. My own college e-cell, again I am an advisor there, my BMS college. And here I'll be there. So VIT, I am part of that. So I think, once you start getting visibility, they have to see value, no, on what you are doing. Correct? Just on name, nobody will sponsor. They have to see value. So if you start positioning today's event, you did a fantastic, you can put it under e-cell. Post saying that today we had a great session by Dr. Deshmukh on quantum computing. I think chota sa write up. Don't make it too big. People have to read it and put some photos. So that is how visibility will come. And ensure that your target, whoever the social media target is, how many students are there in this college? The target for you, all 8,000 students should subscribe to that page. Okay? Then only. Yeah. So that page is not only for School of Engineering and Technology. Your entire college should know. Because everybody, even your law college student is a School of Law student is an ambassador, for VIPs. They should know what you're doing, or what the college has done, or what this school has done. That's the first target for you. All your 8,000, whoever is on LinkedIn among the 8,000, they should be followers of that page. And promote even the alumni. Okay? So though this school alumni will be you'll become alumni, after 18 months, but we should have an alumni track also. We'll do that separately. Okay? What else? Any other feedback? Absolutely, absolutely. I think, I told you, the only purpose of life is happiness. So, I think there is nothing else. Create a robot, that robot is distributing chocolates. I am very happy with that robot. Madam, you did not give me the Cadbury's, huh? I eat more chocolate than my daughters. Both daughters put together, I eat more. So, so what else? Baith jao boss. Tell me, talk.
So now we have started,
Yeah. So other colleges means you must do intercollegiate hackathons or some challenges where you call them ideathon, business plan competitions. So for all those things you don't need us. I think people like me or Madhav or whatever, we'll come in to bring in some senior panelists or speakers or whatever it is. So I think regular activities should keep happening. But since anyway we are either in that WhatsApp group or in the followers on the page, we will know any additions, any things. We will always keep suggesting on that. So, what else? Any other? And you put that logo, ma'am. I think IIC का logo डाल दीजिए उसमें. IIC, ESL, IIC का logo. And I think I suggested that you make one Sanskrit name also for ESL, whatever it is. Nice name. I don't know, whatever. Like I am part of one initiative, very beautiful initiative. I chose that. I am Bangalore. That's only for women entrepreneurship. And that program name is Swavalambane. You know Swavalambane? In Kannada, Swavalambane means self-reliance. I think, even Hindi is called Swavalambane. What is it, Sam? So that program is called Swavalambane. Anything? Yeah. So like that, you choose a good name. So that Swavalambane comes under NSR cell, which is the E cell of IIM Bangalore. Okay, so choose a name. So it will become a brand. Next 5 years, it will become, everybody knows NSR cell Swavalambane now. So like that, you must start building a brand, not just E cell. VIPS E cell, ठीक है, but एक brand कर दो. I think your all these cultural fests have a brand, no, like that. Yeah, should be catchy. Yeah, so make a good name, and it should be long. I mean, it should remain forever, that name. Okay. So what else? Anything else? Yeah. How many of you are teachers here? 2 of you. Huh? Okay. But more mentors are going to add? Yeah. See, most important is, all your office bearers and this team, the most important is it should become inclusive. Each one, if you have 200 students, or rather, how many students in engineering and for engineering and all three years together, it should touch everybody. Actually, for your social media, at least start 1200 ka followers to le lo pehle. At least start with those engineering and technology students should become followers. And you don't have to call personally, you must be having groups or message boards or whatever. Ensure that everybody has a LinkedIn account. That's the best thing. Okay. So, yeah, what else? Anything else?
I just want to add that
Yes, sir.
in law, the word by itself is entrepreneurship, self. I was getting since yesterday, he said, but I cannot relate that. And I love it. 35 years I've done only entrepreneurship.
Correct.
I've been part of heading enterprise, program enterprise, Tata. So I think I would only say that the word entrepreneurship has a shift in it, which has to sail through.
Absolutely.
The captain, the responsibility of the captain to sail that ship with the flag high. And that's the most important part.
Yep.
And it should be moving in the right direction. The ship has to sail. It should not be parked in the harbor. It should sail.
Yes, it should keep sailing.
Responsibility to steer it.
Yeah.
More maneuver where it is required. And the finance and marketing and other So that kind of a synchronization of that shift is required, and that's my essence of 25 years of entrepreneurship.
Absolutely.
As a leader,
Yeah. So I think, Harshji is locally based, so he is more accessible. So though you're equally more accessible online, combination of online, and me and Madhav keep coming here, maybe twice a month or once a month minimum. So you should use Harshji's experience. Kick off the first, let's say, ESL talk on whatever topic he is comfortable or.
I was thinking it's
Yeah.
part of some electronics or technology.
No, I think.
Robotics or.
Yeah. Ma'am, Deepali ma'am, I think you had gone out somewhere. So this is only one slide. This is action plan. So ESL pitch document, I will send you the template. Roles and responsibility, abhi ye document, I'll send it. You have to change the thing. So the rest of it is all the action. Ma'am, I think March end. Before your exam start. Complete. So all these activities are the student. Only these two, I'll send you the templates, but you still have to do it. Okay? Any other feedback, any other suggestions?
I think you should share some ideas with students, means on which ideas they must go on to make a startup, to start a startup.
So,
Very much important.
correct.
Students are, directionless.
No. I'll tell you. That is why that is a common problem. For that, you have the Ideathon. Ideathon, so the solution, yeah. So the Ideathon will generate ideas. And of course, Ideathon karne ke baad, you will have a jury members, people like me or any other. So jury members will come and suggest, a idea theek hai, practical hai, feasible hai, it's, some ideas may be crazy. So through Ideathon only those ideas will come out. It's again back to the students, this also. Because see, ideally, what I don't, if you want to do a project, okay, your idea you should pursue. Mera idea, mera man mein kuch bhi hai. I may want to create some rocket ship with, I saw one beautiful project today, without, turbine engines. But you may not like it, correct? So ideas startups or entrepreneurs should pursue ideas that you are passionate about. Ideally, that is how it is. Okay? And this is actually, sir, all that is part of the roles and responsibilities that is there. Yeah. Yes, there will see the marketing or the editorial person will release a monthly newsletter. Yes, all that is there. Everything is there. Detail hai. This one, I think this is a work in progress, nothing to do for you. But collaboration, once this is set up, the collaboration will happen. I think action is on management, and of course I am assisting. This will be world class. This will only add to whatever you are doing. Okay? What else? Any other feedback? You're all of you happy? How's the Josh? Fantastic. Yeah. 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 Yeah.
We can give you a board, we can provide you a board, we can provide you everything. That can use people now. We are here, everybody of there is, sir is with us, your Gobasa is with you, Uncle is with you, I am there, sir is there, everybody is there to guide you, but you people have to make it.
Proactiveness, initiative is you.
If you people think so, then you will see only like this and papers will come down
See, these people, I will tell you how they behave, especially VIT May or BMS College May, the marketing head of this thing. He thinks he's like a marketing, director of a company. That pride you should have. You should have that pride. That boss, मैं इस साल का एक ही साल का रोल है, ठीक है. Okay, so and also once you finish the first year, then move. There should be a smooth transition with the help of the management. The next office bearers should take over smoothly. So they should.
We are in combination of third and second year. Third and second year, both the teams are best.
And first year also.
First year also. So when you are asking how the transition will be done, you are going to go to second year, second year.
Yeah. So whatever, 1 year period, ma'am. Ma'am, whichever year they are in, this role is for 12 months. So next year you may again have a mix. But after the first year, the transition should be smooth. I don't have to come and give another talk like this. I am spending time only because this is the first e-cell launch or first batch. Otherwise, I don't have to do this. You should do this and transition slowly to them. Okay?
So we select a very good breakup and we will do that.
Thank you. Thank you. All the best. I think all this claps is fine. I'll be really happy to see 1 year some great events coming out of this. And for me mentally, I know the benchmark. You're not seen. I know what kind of events I have rolled out in VIT, BMS College. So I will tell you if it matches that or not. Okay? After 6 months. Okay, thank you. Take care. All the best. Okay.
Just say, I don't understand if it makes us proud. We'll about that, but we are
Whatever, see, all of us are available free. That means we are not free floating. Ensure that they are part of your roadmap. When Harshji has to come next Thursday, it should be in your roadmap. Give him enough notice saying that, sir, Thursday, aapka talk hai, aa jaiye, and follow. Deepali ma'am should not be involved in this. No, not involved means she should be aware, but she should not be spending time on this. Okay, she has other things to do. That's how it should run.
taking some take care of this. Because sir is the best person.
Cake, icing on the cake. And let me give you a cherry on the icing on the cake. Right? The cherry is that if at all I am taking an interview of somebody, and he writes in his interview in the series, I was the president of an e-cell, and we did that and we did that, right? I will give him some positive marks. Provided he or she is able to explain me well what he did, what she did. Because that both are important. Just writing doesn't happen. You should be able to express what you did, how you did, and what you achieved at the end of that. The end point is very important. Now he says, Ganga is not important. You are appointed as a board member is not important. But what you did and what you achieved at the end of that. That's entrepreneurship.
Yes, sir.
Right? And the bottom line should come, profit should come. Right? It's not a very good profit should come.
Maybe the board will be involved. Sir is there to guide man also.
Thank you so much.
Everything has to be done on the first time.